Hello, this lesson is on organizing data for statistics. So before you can organize data, you have to know what kind of data that you're working with. So we're going to cover how to categorize your variables, how to decide which one is which, and then ways that you can display it in a manner that is pleasing to the reader, that the reader can understand, and that you display the information that you're actually trying to display. So I really like to use technology for graphing out data because it's just a lot more professional, very nice and neat, very clean. And if you do it by hand, it's a nice sketch, but it's not as precise. So there's a lot of really cool technologies you can use to graph your data. And I will show you a few of those today. A brief view, not an in-depth view, but let's take a look at the notes, and I think I'm happy with that view, so we'll leave it. I mentioned that we would talk about categorizing your data. So whenever you're researching something or studying something, what you're studying is a variable, which is a characteristic that varies from one person, or it might be, instead of a person, a subject. You could be studying animals or something, from one subject to another. In statistics, there are two types of variables. There is quantitative and qualitative. And if you think about the root of those words, you can kind of figure out which one is which. So quantitative refers to numerical data. And within quantitative, there's two types. There's discrete and continuous. So discrete is kind of like whole numbers, which means that you can list them easily. Now it may extend indefinitely, but you can list them. So like 1, 2, 3, 4, 5, and so on. Whereas continuous is more like rational numbers, and it's more of an interval. And we'll look into some examples of these later on. Qualitative is like quality. You might also see this referred to as categorical, is a non-numerical data. So it could be something that's not a number, which means like hair color or something like that. And then within qualitative, you can have binary data, which means binary means two. So that's where there are two answer choices, which would be like male, female, yes, no, stuff like that. Two choices. That means binary. And then I have some examples down here. The picture's a little bit fuzzy, but I think you can get a good idea of the flow chart. Types of variables, there's two, qualitative and quantitative. And then it has some examples of qualitative: brand of PC, marital status, hair color. And then within quantitative, there's two types, discrete and continuous. Discrete would be number of children, number of TVs, and so on. Continuous would be those decimal numbers where like it could really be any number, like a height or the speed of a train, or it mentions amount of income tax paid, because it could be decimals when you talk about cents. So anything that can be expressed as a decimal is going to be considered continuous. We have some examples down here. If you would read through the examples, pause it, and then decide which one you think it is, and then come back. And when you come back, I'll tell you the answer. So I'm assuming you've paused it and now you've come back. The first one says humans have one of four types of blood: A, B, AB, or O. I know within those there's positive and negatives, but we'll just go with those for the categories. What type of data is this? This would be qualitative. They are not numbers. Would this be binary or not? No. Very good. No, because there's 4 options. That's not 2. Next one says the Census Bureau is collecting data on household size. What kind of data is the number of people in your household? It says right here number, so that's going to be quantitative. Can number of people be a decimal? No, so this is going to be discrete. Now, when they report statistics on what they found, you might see the average household has 2.5 kids. They don't mean half of a kid, they just basically mean between 2 and 3 kids. So they found an average. Moving on. Each piece of data is called an observation, and the collection of observations is called a data set. There's some vocab for you. And then we've already kind of talked a little bit about examples, but I want you to pause this and try to think of your own examples for these. I've already mentioned a few, but maybe you have something else in mind. Pause it, come back. I'm assuming you've paused it. And so an example of quantitative variable would be, I'm going to say height. You could say weight, anything that has to do with a number. An example of a discrete variable would be number of cell phones on your plan. And a continuous variable would be, I mentioned speed of a train. I could use that again. Speed, I'll do a car on a given road. And then an example of qualitative variable, anything that is not a number. So I already mentioned hair color, already mentioned, let's see, having trouble coming up with another one. I guess I'm going to write hair color on the spot. I could do favorite color. Ooh, you know what I could do? Favorite political candidate. That's one, because that's not a number, that's a person. Oops, that looks funny. It's not candidate road. I'll fix that. There we go. And then an example of a binary variable would be like a yes, no. Do you eat veggies every day? That would be a yes, no answer. Okay, so now that we know the difference between the types of variables, and hopefully you could be able to decipher which one is which, then you have to decide how to organize your data. So organizing qualitative data looks different than organizing quantitative data. I always get those two words mixed up. They're very close, mean very different things, but they're very close. So qualitative data, let's talk about first what you might think the word frequency means. So think about that for just a second. You can pause it if you need to. In my mind, when I think of frequency, I think of how often something occurs. But I have a math mind, so I don't know if that's what y'all think. If it's something like that, then you're good. So if we take that word and we apply it to a frequency distribution, that is a list of values and how often they occur. So it's just a way of organizing data sets. And a frequency distribution table usually has 3 columns. And these are really nice for large data sets where you've got all this data and it's all just jumbled up sitting there and you can't really make sense of it. So if you can make a frequency distribution table, then it organizes your data and you can kind of see how it's distributed. If you look at this table here on the right, it's kind of got like a little curve in the middle and then it kind of flattens back out again if you tilt your head. And basically these tally marks, I generally think of it as like there's a big list of values. They wouldn't be numbers, they would be, oh, this is a score. So 1, 2, 3, 4, 5, 6, you counted up how many of each occurred. tally them up. When you reach 5, that's when you have the little cross mark. That means 5, in case you're unsure. And then you keep tallying. And then when you're done tallying it all up, you have your totals here. So that's a frequency distribution table. Very straightforward. And you might also see from that a relative frequency, or RF. And this is the ratio of the frequency to the total amount. So you're basically seeing what proportion is this value of all the values. So you take the frequency, for example, here, and divide it by the total number of items. And this, just like I mentioned, it gives you a proportion. It provides you a standard of comparison, and it helps us build percentages. So relative frequency gives you that ratio, which is a rational number, which leads to a decimal number, which leads to a percentage. And you're seeing, oh, this percent had a 6, this percent had a 5. So it all kind of leads together. And those are very simple to construct. I have here to construct a pie chart. The easiest way I know of to construct a pie chart is to build a relative frequency distribution table in Excel. Convert the relative frequencies to 100, and to do that you multiply, I'm sorry, I said that wrong. Convert to a percentage, and to do that you multiplied the decimals by 100. And then you can pull down a pie chart and use your data in your pie chart. Oh, this was to do by hand, multiply by 360. I would not recommend doing it by hand. You could probably get a rough sketch of it by hand, but it's pretty bad usually if you don't have the right tools. So this is by hand. I jumped ahead of myself. This one was in Excel. This is a screen capture. I did this one in Excel. I just did desserts, how many people chose those desserts, the relative frequencies of those choices. I pulled down a pie chart. I grabbed my data and dragged it in there, and it just populated it for me. I didn't have to have a circle. I didn't have to measure out angles. I didn't have to do any of that. It did it all for me. It was very straightforward, very easy to use. If you don't have Excel, I'll show you something you can use a little bit later in the lesson. Another display for qualitative data is called a bar chart, and you've probably seen a bar chart before. A bar chart displays distinct values on the horizontal axis and the relative frequencies on the vertical axis. So I did another example here. I actually used the same example as my pie chart. I used the same table, the same everything, but instead I pulled down a bar chart, drag this stuff over here, and it populates for you. And then you can kind of mess with the display. You want to make sure that you label the axes very specifically. You want to be sure to label your key. You can add these in there if you want to, so there's a lot of customization. I like having the relative frequencies there because sometimes it's a little hard to tell. So you want to give your reader as much information as possible without overwhelming them. You don't want it to be too chaotic. You want it to be very clear and very easy to read. So that's what that looks like in Excel. Whoops. So just to kind of review a little bit, I want you to pause and think about these. Explain the difference between these things. So pause it, think about it, try it on your own. And then when you come back, I'll go over it. So frequency is just a number. Number of times an observation occurs. And a relative frequency is a ratio of the frequency over the total. And remember, the total is not the total of the values, the observations. The total is the total of how many observations there were. So you have to be very careful about that. Sorry, my dog is sneezing. Next one, percentage. The percentage is your ratio or your relative frequency times 100. So for example, if your relative frequency is 25 and you multiply by 100, that's 25%. And then we already mentioned the relative frequency is the decimal form or the ratio. So just kind of familiarize yourself with those differences so you know how to use them properly. I have an example down here. These are M&M colors, and the frequency column is already filled out for you. So someone already did the tallies and they counted them all out and separated them. It's very tedious work if you've ever done it. And these were the values they got. So I want you to practice calculating the relative frequency and the percent based on these values. So pause it if you need to, work on it on your own, and come back. And I've done it ahead of time so I don't waste your time in this video. When you total these up, they should total up to 505. And then your relative frequency is going to be the small number over the large number. Sorry about my dog. He is so cute, but loud. And then I'm just setting these up as fractions for right now. And then I'll get the decimals in just a second. Luckily, I love when there's two that are the same. It makes it so much easier because you don't have to do it twice. Actually, I'm going to do this little wavy equal sign means approximately because I'm getting rounded decimals. So you're only going to put equal sign if it is exactly equal, like 1/4 is exactly equal to 0.25, whereas these are going to be rounded. So this decimal is 0.297. I didn't check myself on these, so I'm hoping they're correct. If they're not, then email me. No, I'll check them in just a second. I'm teasing. I wouldn't want to leave you hanging like that. I'm just going to check my total one more time. I've been wrong in a video before, so you can never be too sure. You always want to check, make sure that you've typed in everything correctly. I did get 505, so I'm pretty confident in my other answers. Yeah, I feel confident. Okay, anytime you're doing stuff like this, it's always smart to either type it in one more time to just double check, or go back and look at your calculator and make sure that you typed in each number correctly. It does matter and it does make a difference. So if I were to convert these to percentages, Sergeant, you're killing me, lay down. You would take 0.297 times 100 and you will get 29.7, 21.8, 20.8, 9.9, 8.9, 8.9. Those are percentage signs. I always have a bunch of students say, is that a 9? No, it's not a 9. I just can't draw percents correctly. What I want you to do now is total these up. So pause it if you need to, and then come back. I'm going to do it also. Make sure you're typing it in correctly, not incorrectly, but inputting it, whatever. You know what I mean? Yay, it's perfect. It worked. Okay, I wish I could show you this. This makes me so happy. So I typed in my decimals, I added them up, and you can't see this because the calculator is small. It came out to perfectly 100%. That is so rare for me. It's usually 99.9 or 99.98 because of rounding error. But this added up to a total of 100%, which is awesome. So that means that since they add up to 100%, that I calculated all of these correctly, which also means that these should add up to 1. That's 100 in decimal form. So that's a really good way to check your tables. If they're not close to 1 and 100%, then you've done something wrong. You need to go back and check it. If you're getting like 89, 92, that's not good. That's not even close. They need to be like 99.9 or 99.98. They need to be very, very close to 100. So that's qualitative data. Let's move on to quantitative. Remember, quantitative data are numerical variables. So sometimes you can group quantitative data into classes or categories or bins to make the data more understandable. So sensible class sizes range from about 5 to 20. All classes should be the exact same size, and there should be no overlapping of the numbers. And then basically you group data like this when the data sets are really large. So if you have like a data set of 2,000 observations, it's gonna be really hard to make a bar chart or make a graph of that. So if you can bin them, then it makes it a little bit easier to read. And you want to make sure that your classes don't overlap. So for example, if you have a class that goes from 50 to 59, then the next one needs to start at 60. So you start at the next number. If this had been, 69, then there's overlap and your graph would be wrong. So you want to make sure there's no overlap. You also need to make sure that your class sizes are the same. So all of these are 10, a length of 10. I'm going to sneeze. I hope I don't sneeze. Okay, in some cases, a single value class makes sense. So an example where a single value class maybe would be more efficient would be like a discrete variable, like number of TVs in a household. That's going to be like 1, 2, 3, 4, whatever. So you don't need really to do class sizes on something like that. If you were doing grades or ages or heights or something, maybe a continuous variable, then the classes make sense. This next line just kind of ended up in a weird spot. It actually goes to the next page. So charts used to display quantitative data are histograms, dot plots, and stem and leaf diagrams. So a histogram is basically a bar chart, but all the bars are squished together, and they're used for quantitative data. The easiest way I have found to do histograms, these are surprisingly hard to do, hard to find software to do it, are in PowerPoint. And then you can also do it in TI-84 if you have that. There's some really good videos on YouTube on how to do that. Dot plots, Fathom, which I told you I was going to talk about, is a really easy way to do dot plots, and then also at TI-84. And then stem and leaf diagram, you can do this in Excel or by hand. By hand's pretty easy. Sergeant, get over here. I'm sorry, I don't know. Fathom is a $5, maybe $6 program. You get to use it for the whole year, and you have to download it onto your computer. It is so easy to use, and I just love it. And especially for, I think it's $5.95, but especially for $6, it's really nice. I'm thinking I want to show you that really quick. I actually have some examples down here of what it looks like. Here's one at the bottom of the page. You literally, it's like a drag and drop thing. I'm going to show you. Even though my dogs are misbehaving like crazy. going to share my screen. I'm going to show you Fathom because it's so wonderful. When you open it, it'll say, this version of Fathom expires on whatever. I bought a year back in July. And literally, you pull down, I'm dragging it down, a table. You put in your variable, we'll say. I'm just going to put in some random numbers. I'm just making something up. And so I have my data. Now I'm going to pull down a graph, drag it over. I'm going to grab this X, drag it over. Isn't that so neat? That's a dot plot. Done. Didn't have to do it by hand. Super easy. They also have line plots, histograms. So if you don't have PowerPoint, this is a $6 alternative. And box plots, percentile plots. We'll get into all that later, but this is pretty neat. They don't have a stem and leaf, but they do have a histogram and a dot plot, which are really good ways to display quantitative data. And then you can print this, I believe, directly from the program. I used, when I was doing homework and stuff, I used this snipping tool, and I would do a screenshot of this and put it in a Word document. So there's lots of really cool ways I would copy it. Hit copy, put it in a Word document. Super easy. I love this program. It's very neat. So that's Fathom. It is about $6. You have to download it onto a computer. You cannot download it onto an iPad, but it is worth the money. I'll tell you that. Let me get back to my iPad and share this screen so we can finish this lesson. I'm sure this video is getting really long, but I am just confident that you are just so interested in all the stuff I'm talking about. Also, I did mention the TI-84 being an option. Here's an example of the TI-84. I didn't put the instructions for that on there for some reason. If you just Google it or type or look for it in YouTube, there's tons of videos on how to do this stuff in a TI-84. So you can do that. I think I wanted to focus on Fathom for this because of how simple it is to use. So there's some examples of that. There's another example, a dot plot. Make a stem and leaf plot. Okay, so this one you're going to try. You're going to do it by hand. You're going to make a stem and leaf plot for this data. Oh, you've never made one. I'll show you. A stem and leaf plot is kind of like a little T chart. And on this side you have the stem. And on this side you have the leaf. And the stem, I'll start with the leaf. The leaf is the rightmost digit. So if you had like a 5-digit number, the last digit would be your leaf. And then your stem is everything else. And they have different ways you can organize these, but I'm just going to show you this one way. You can see in your data that you have 20s, 30s, you highlight them, 20s, 30s, 40s, 50s, and 60s. So let's kind of set up your lines. 20s, 30s, 40s, 50s, and 60s. There you go. And then you're going to list your data in order, and you want to keep them nicely spaced. So in the 20s, there's a 20 and a 21. So in my stem and leaf, this stands for 20 and 21. And then I'm going to keep the same spacing on my next one. I'm going to mark those out because I've used them. We have 32, 32, 37, 38. And then on not number 4. For 40s, we have 41, 43. So even though these numbers are not the same, that doesn't matter. They just need to be evenly spaced so that it's all proportional, because we're going to kind of tilt our heads again and look at the shape of it. to see kind of what's happening. And then 55, 62. So this easily tells us, let's say these are ages, maybe ages of teachers, I don't know. This tells us easily that most teachers, I'm just making that up, I don't think this was teachers, but most teachers at this school are in their 30s. You have a couple in their 20s, that would be too young for teachers. We'll go with it, maybe they're aides or something. A couple in their 40s, one in their 50s, one in their 60s. So that's what a stem and leaf can tell you. I have an example down here that you can try on your own. I believe it is the last example. So go ahead and hit pause, try it on your own, come back and check it. And maybe you're coming back to check it. So like that. Okay, it looks like I have 5, 10s, 20s. I don't see any 30s. So I'm going to put a 0, 1, 2. So my 0 is going to be the 5, 8, 9. Are there any other 1 digits? No? Okay. And then you'll look at your 10s. There's a 10, a 10. Sometimes it helps to put these in order first, but I like this method, so I'm going with it. Any more 10s? 11, 12, 13, 14, 1, 2, 3. Might run out of room here. 15, 15, 16, 16. I am going to run out of room. 17. This is what happens when you do it by hand. My spacing got off, but I think we have a clear winner here. Let's see. And then we'll look at the 20s. There's a 20, 2 22s, 2 23s. I believe I got them all. So my spacing did get off here. I would recommend that you not be as sloppy as me and space it out a little bit better, but you get the idea. So that's all I have for organizing data. I hope you enjoyed it. If you have any questions, let me know and I'd be happy to answer.